Hi guys, welcome back to another video in this channel. Today we're going to talk about a very interesting subject. This is going to be a short video, but I hope you guys like it. So, in the comments a couple of days ago, someone asked me on the, I think it was on the final one that we did for the helmet, by the way. If you haven't seen that one, I think we got to a very good result, so make sure to check that one out. But someone asked, hey, what's the difference between CPU and GPU render? And that's one of like those topics that sometimes, or not sometimes, once you get like enough experience in a field, you sometimes forget, and that's actually like an issue, I would say that's like an ego issue. You forget that there's people that sometimes they're starting and they don't know anything. So thank you for asking those questions, because that allows me to explain to you all of the very basic stuff so that everyone feels welcomed in this community and can start learning 3D as well, as we all did when we first started, right? So well, very basic stuff. CPU is the what's the word? It's the processor that you have in your computer. In my particular build right here, you can see that I have an AMD Ryzen 7 5800X, which is an 8-core processor. I would say it's comparable to an i7 from Intel, if you're using Intel's. And what this means is, as you can see, it has 8 cores. So think about cores as brains. It has like 8 brains, and then those brains in total add up to 16 logical processors. So when you throw in a render, or when you start a render, or when you're doing a lot of things inside of your computer, those brains like act together and they solve, or they find the solution to whatever you're doing. And we know that at the end of the day, when we're taking a look at renders, what we're trying to calculate is how shadows, lights, materials, and everything react. So this thing right here, this is actually a file from the Blender archives. I thought it would be a little bit faster to show it in Blender, but you can also do a test inside of Maya if you want. And this was done by Oksana Dobrobolska. I'm gonna say she is a female artist, probably. So well, they did this this project, this Glacier project, and it showcases a couple of the like new features that Blender 3.2 has, which is some like caustic and shadows effect. So if I were to go over here, you can see on this area right now, I have this set to GPU compute. I'm gonna change this to CPU. It is using some experimental features, but I'm going to change this to CPU. There's some noise thresholds and stuff. I'm going to set this to 60-second limits so that it doesn't take as long. And as you can see, we do have the denoiser active, which is going to help us solve a little bit of the processes. So I'm going to pause this video real quick, guys. I'm just going to hit render and render image right here. I'm going to pause real quick and I'll show you the result as it's finished. Okay, so I think I can still record. I've been having some issues with the OBS where it just like goes overboard on the memory, and I can't really record because the audio just breaks down. But I think right now we're doing okay. And as you can see right now, what's happening is the processors on my computer, they're trying to solve all of the information that we have in the scene. So they're calculating bounce light, volumetric fog, refractions, reflections, the caustics, like every single thing that we're seeing here, it's being solved. I only gave this thing 60 seconds, so it's not going to be as clean. You can see here that we're only left with 15 seconds, so the image won't be as clean, but you can see how the samples are like starting to look, right? And I only want to give it 60 seconds to make the video longer, but I've run some tests with this scene in my computer. It takes about like 10 minutes to get a nice render, which is quite a bit for a full scene, but it's also a really beautiful render. So yeah, there we go. So this is the result, as you can see, of my CPU doing everything it can to what's the word, to solve the scene. And right now, yes, it looks a little bit blurry. You can see some of the edges are not that great, but that's not because the CPU can handle the processing. It's because we didn't give enough time to the render. If we let this run until it finishes, or until it hits the sample amount that we're like giving it, we would get a really clean image, and I would expect to get like this exact image that we're seeing right here with all of the details and stuff. But it's not bad, right? Like for 1 minute right here, this is not bad at all. So I'm gonna save this image. I'm gonna go image. I'm gonna save this. Let's save that on the desktop for now. Let's call this Glacier CPU. I'm gonna save this a PNG, no compression, or let's just save it as a JPEG instead, and let's go 100% quality and just save this image. So if we go to the to here real quick, you're gonna see that this is the image that we have. I mean, we're gonna compare this. We're gonna compare this with the GPU so that we can see the differences. So we're gonna jump back into Blender. I'm gonna go here, and this is the important bit. We're gonna change cycles. We're of course using cycles. We're not using if. If uses, I believe, like just a traditional like viewport rendering. So cycles and then GPU compute, very important, and super important. Make sure that current preferences, you're using either optics or CUDA cores, depending on which one you prefer. I've found some conflicted information about this one. Let me explain real quick what this is for everyone that's new. NVIDIA cards have something called CUDA cores. And CUDA cores is a technology that they have in which they process information in some way. That's something like above my pay grade. I don't know how the technology works. I just know that it's a proprietary thing from NVIDIA. So if you're using an NVIDIA GPU, especially a newer one, like from Series 10 onwards, you're going to be dealing with CUDA cores. The more hefty your GPU is, or the pricier it is, the more more powerful and more CUDA cores you're going to have. And CUDA cores allow you to do a lot of different things. They're being used for a lot of different things. Unfortunately, not everyone has an NVIDIA card, and there are, of course, AMD graphics cards that are really good as well. Usually, my best advice is if you're going to be doing 3D work, I strongly recommend, like 99% of the times, get a GPU card, because a lot of softwares like Substance Painter, Unreal Engine, even like Maya, Blender, like they work a lot better with the CUDA technology than with the AMD technology, because unfortunately AMD, well, I'm not sure if it's AMD or who it is, but they haven't invested as much on that kind of technology, and all of the other companies have gone into like the NVIDIA environment. So that's just like part of the situation. But if you have an AMD card or any other card, there's this other option which is called the optics solution, and optics uses, again, another type of computation. Optics is, I think it's also created by NVIDIA. I'm not sure though. Let us double check. I don't want to be saying I don't want to be saying lies. I'm not sure who develops optics. No, optics was developed, sorry, I think it was developed by Intel. So optics 3D. Is it something like this? No. Is it NVIDIA? I'm not sure. Yeah, I'm not sure if it's this one or not, but the point is that optics is another way, and it's open source. So in the next couple of years, you're going to see more and more softwares using optics technology because it's really good. Actually, in Maya, when we use the denoiser, we used it on the helmet and on a lot of our classes. It uses optics technology, which is pretty much the same thing. Well, it's not the same thing, but optics technology gets or understands what kind of components your graphics card has and uses those to your advantage. Again, I've read some, I've done some research, and I've read some conflicting results whether CUDA or optics is faster. It seems that certain things are a little bit faster on CUDA, certain things are a little bit faster on optics. I'm just going to turn on AMD Ryzen. I don't want to be using any CUDA cores from this, which actually I don't think it has. So we're just going to be using NVIDIA right here. We're still going to keep it at 1 minute, and then I'm going to say render, and we're going to render the image. Here's where we might get some audio issues because OBS works with GPU as well. So while this thing is rendering, it might have a little bit of a different effect. You can already see that this is going faster, but I'm going to explain why this is in just a second. Let me pause real quick, and I'll come back when this is done. Very well, so the render is done. Again, we gave both render CPU and GPU pretty much the same amount of time, and now let's see how nice or the difference between each image. Let's save this one. We're also gonna save it as a JPEG. There we go, 100% quality. We're gonna call this Glacier GPU, and we're gonna save the image. So before I explain my understanding of what this thing are, so let's just take a look at the differences. And you can see that there is quite some noticeable differences. This is the CPU and this is the GPU. And you can see that it changes quite a bit. Now, which one is better? Here's the funny part. This one has more detail. As you can see, like on the ripples on the water, this is the GPU, by the way. As you can see on the ripples on the water, it has way more detail. Like the foam here on the water, it's a little bit more detail, especially like closer to the elements. But take a look at the shadows and the caustics here on the glaciers. See how on the GPU they look really blurry? And take a look at this. Look at how nice and complex the shapes start looking like. Look at this part right here, and just see how more like defined we see like the divisions there on the caustics reflecting. And this is one of the selling points of 3.2 and in Blender. Like see same thing. Like watch the shadows right here. The GPU, it pretty much just gave us a flat shadow, and see how much more information and interesting things we got right here. Take a look at the lights on this top corner right here. Again, this is a GPU, and look at the CPU, way more interesting, way more exact. And there was a video a long time ago that I saw. This was like 10 years ago or something, which was by the Mythbusters. If you haven't seen this video, just look it up like this: GPU, CPU, Mythbusters. And this one, look at this, December 4, 2009. This was done 12 years ago. 12 years? Yeah, or 13 years ago. 13? I'm bad at math. But yeah, it was done so long ago. And what they explain right here, I'm not gonna like play it right now, but what they explain right here is that CPU, the processors of a CPU a processor, are way more exact. They're like super precise, so they're gonna give you the most realistic looking effects. So in this case, if we're looking at caustics and light reflections and shadow interpolation and things like that, CPU is always gonna give us the cleanest result. It's gonna take longer because it's really meticulous on like finding and solving all of the equations in the best possible way, but it's gonna give you an amazing result. GPU, on the other hand, they use like this super big like cannon or like air cannon thing. It will give you a really good result really fast. It's more like a shotgun approach. So they will just fire a lot of processors because the CUDA cores, they're like mini processors. So for instance, I have the 3080 Ti, and if we check how many CUDA cores we have, it has 10,240 CUDA cores. So imagine like 10,240 small processors instead of 8 that we have on the main processor. We have 10,240. But imagine those are like little kids, right? Like 8-year-olds trying to solve math problems, and the other ones are like top-level geniuses, like they've been doing math their whole life. So we know that the result from the geniuses is going to be a lot more precise. But we have a massive amount of volume on the GPU. That's why the GPU is so powerful, and that's why, especially for studios like mine, where we're a small team and we don't have a render farm or anything, having the ability to create very quick, fast renders using GPU is really good. Now, as you can see, I mean, you can evaluate for yourself which one of this looks better. I personally think that the CPU definitely has more precision to it, but the GPU is not bad. Like if I were seeing a series or something with the GPU render, especially if I let it run for a couple more minutes, I'm pretty sure we will get an amazing result. But here's one thing that they don't tell you about, and this was taught by a teacher of mine. He used to work in the Bad Robot, J.J. Abrams' like production house, and I think, when was it that I had class with him? It was 2015. That was when I had class with him, and it was always the question, hey teacher, should we try doing GPU, should we try doing CPU? And he's like, at that point, like 7 years ago, he's like, GPU is not ready yet, because the problem with GPU is that the graphics cards, they're not really built to withstand like working at that voltage and at that like intensity for so long. They just burn out. So processors, yes, they take longer, but they can run at full like processing power without overheating for longer and longer periods of times. Nowadays, the technologies are going like mix. Pixar has this very cool thing called XPU, where they mix CPU and GPU. I think that's going to be eventually the main thing. And the car manufacturers working on like bringing the temperatures down and everything. Thankfully, crypto mining has been going down the last couple of years. Some of you guys might remember how difficult it was to get a cheap GPU in this last couple of years because of the crypto thing. So yeah, I mean, if you're thinking about like, I'm building a system and I want to be doing a lot of GPU renderings, just keep in mind that you're going to be doing long periods of GPU rendering, like you're going to be rendering whole sequences and stuff like that. I would strongly recommend either to look into render farms or to try and see if CPU can also solve your issue, because the worst thing that could happen is you're running a really high-end system and you run it for like 3 or 4 days straight trying to render a film or like a short commercial or something, and then just burns, right? Because that's the other problem. Graphics cards are a lot more expensive than the CPUs. So for instance, if my CPU were to crash right now, hopefully it doesn't, right? But if it was to crash right now, I could get a new one for 6,300 pesos, which is about $300. So for $300, I can get myself a new processor, and that's it. I'm completely fine. But if I want to get a 380 RTX 3080 Ti, like right now, the cheapest one I can find, look at this, 23,000 pesos. So it's way more expensive. So I wouldn't suggest risking your system and risking your rendering experience for long periods of times. The longer I've gone, it's probably like 8 hours, like overnight, and then I let the computer rest for a while, and then I keep going. So just keep in mind, if you're doing GPU, make sure you have your temperatures like properly set up so that you don't run into that problem. And that's it. I think that's all the information that you guys might need. If you're still looking for something interesting to learn and you want to try, remember we have this very cool Skillshare promotion. Hey guys, Abraham here. I just wanted to remind you guys that we upload all of our courses to Skillshare. Skillshare is this amazing site where you can access a ton of different content to learn, improve, and grow as an artist. We have all of our courses available to watch and learn from right now in Skillshare. You can check the description down here, and Skillshare is offering 1 free month trial to their premium membership. With this membership, you're going to be able to access all of our courses and watch and learn all of the amazing things that we cover with all of the softwares. So, what are you waiting for? Check Skillshare down here below. And there you go, guys. This weekend is going to be a little bit tight for me on the schedule side of things. We've been having so much work here at the studio. Amazing projects, really, really cool ones, but a lot of work. And since there's a couple of artists that are still kind of new to the process, so there's a lot of coaching from my part, I will still have to do a little bit of overtime and things like that. So I'm probably gonna be gone for the next couple of days, but I'll be back really, really soon to keep on working on some of the projects that we're still pending. We need the boots, we need to finish the boots, and we need to finish the lighthouse. I think those are the 2 pending projects. There's a couple of other topics that people have requested as well, and yeah, let's see what we do for that special day at the end of the month. So thank you very much, guys. You can always help us by liking, sharing, and subscribing. Let your friends know that there's this amazing YouTube channel where we share a lot of 3D content, information, tutorials, and everything you might need for your 3D career. And yeah, thank you very much, guys. I'll see you back on the next one. Bye bye.